Good morning, guys. This is the other version of the test. So I'm gonna go over. Um, so it's very similar to the previous one, except at the end a little bit different, but everything else is kind of the same. So here they want you to determine whether it's true or false. So we have to do log VR, right? Log base b of r minus log base b of 5. In this case, we get the same, so this is true, right? Now, what about this? Here you can think about this way. I have 1 over t. 1 over t is the same as multiplying 1 over t times log BR, right? So we can just move these to the top, right? So then we can say, we can use basically the power rule but backwards. So this is log base BR 1 over t, right? And we get the same this time. So this is true. What about this one? So this is again the base of change formula, right? So we just need to do log C of A. Remember I told you this is the denominator, right? I mean your base, I'm sorry. This is your base and this is your number, right? Let me put that in different color. So this in green is your base and the A is your number here, okay? So that's it. So this is not true, this is false, okay? Because we don't get the same. Here, this is true. This is the thing I was explaining to you in the previous video, but it's a little different, right? Because in the other video it was like this, right? But this time it's not like that. So we can use the power rule here. So this is t log base b a b, and now we need to expand this, right? So this is going to be t log, because I have a product, I can use the sum, right? So log b of a plus log base b of b, you know that that's going to be 1, right? So this is t log base b of a plus 1 times t is just t. So in this case, this is true. Okay, very easy. This one, you can do many ways, right? I'm gonna do the way that is easy for me. So I'm just gonna say, well, this is a binomial square. So this is a minus b, the expansion, right? So I can say a squared minus 2ab plus b squared. That's what I'm gonna use. So I'm gonna say this is gonna be 5, right? Minus 2 root 5 root 6 minus 6, right? So this is gonna be, give me 1 second. That's 5 minus 2 root 5 root 6 plus 6. Okay. So this is going to be 11 minus 2 root 30, right? And I cannot simplify that further, right? Using this formula. Okay. Or you can do this if you want to play safe or you don't know what's going on. You can do FOIL, right? You should get the same. So here 5 and 5, remember this is 5 times 5 is 5, right? 6 times 6 is 6, and that kind of situation. So I'm doing this times this. So that's just going to be 5. And then you're doing this times this now, right? So that's going to be 5 root 6. And then you can do this and this, right? So that's going to be minus root 5. I mean, root 6 root 5, right? And then you have the last one, right? This one and this one, right? So that's going to be positive 6. Now you combine these two, right? That's going to be 11. And this is the same, right? This is like combining like terms. So this is going to be 2 root 30, right? If you do one step at a time, 5 times root 6, it's going to be root 30, right? And then you have 2 root 30, so you have this, right? And that's going to be negative 2 root 30, right? So the same thing. It's up to you what you want to use, okay? This one is not difficult at all. This one, you just need to remember, if you have, the rule is this, right? So you have a cube root of a over b, let's say. you can break this down as cube root of A, cube root of B, right? That's the rule, but here you can go from right to left, right? You can go from right to left here. So I'm gonna go this way. So I'm gonna say cube root of 40m over 5m. So this cancels. So that's gonna be cube root of 8, which is gonna be 2. And that's it. This one. So here you can do, if you multiply the numbers, you're gonna get a bigger number, right? You don't want to do that. So you can just say, well, this is 3 times 4 times 5. That's a prime factorization. 4 and 5 is from this, I'm sorry. 4 and 5 is from this 20 right here, okay? The C, I'm gonna leave it as it is. The C, I'm gonna leave it as it is, right? And then I have Y4, and then I have C, right? Now, the 4, 3 you don't have, doesn't have perfect square. This is not a perfect square. 4 comes out, 5 stays inside. So I have inside 3, 5 so far. The C stays inside, right? Because that's just 1. Y4 comes out as Y2, right? Because you can think about, the way you can think about this is like 4 divided by 2, or like this, right? Remember this radical? Remember this radical means the same thing as, let's say a 1/2, right? So this is a 2 here, invisible 2, right? So this is going to be 1/2. So this is going to be y over 2, right? So that's the reason I get y2. And now you have c, 2 c's, right? So that's going to be, yeah, you have 2 c's, right? So that's going to be c squared, right? So therefore, that's going to come out as 1, right? But when it comes out as 1, you have to put the absolute value, right? Don't forget that, because this index is even, right? So you need to put the absolute value, okay? If it was odd, it's okay, but because it's even, you have to put the absolute value. That's it. That's the end of this problem. Okay. Okay, this thing. Here, you have to solve the equation, they say, right? So you can do this, 3, and you distribute this binomial here. Distribute this binomial, this thing right here, with this, multiply by that 2, right? So you get 6x plus 2, and it's e10x times e to the 4. I'm just gonna cross multiply that, okay? So now you have e6x plus 2 equals e10x plus 4. Now you have the same base. Now you set up the powers equal to each other. So you have 6x plus 2 equals 10x plus 4. That's going to be 4x. You can do this algebra, I'm assuming, right? So 4x, and this is going to be negative 2 divided by 4, 81/2. Okay, that's the answer for this problem. Next. So next we have this one, right? So you can just make it the same base again, right? So this is going to be 5x squared minus 4x plus 5 equals 5 squared. So this means that this is x squared minus 4x plus 5 equals to 2, because you have the same base right here, right? Same base. Set the exponents equal to each other from this rule, right? So now we solve. Okay, so this is going to be negative 2, so it's going to be plus 3, x minus 1, x minus 3, right? Because negative 1 times negative 3 gives you positive 3, negative 1x, and negative 3x give you negative 4x, right? And now you set it equal to each other, and then you're done, basically, right? So this is x equals 1, x equals 3, right? And that's the end of the problem. Remember, when you're factoring, this sign tells you the signs are going to be the same, and this tells you what kind of sign is going to be. So since the signs are going to be the same from this sign, then by this sign tells you that both are negative. So just remember that, okay? So this is the answer. This one. So here, again, same thing, right? This exponential equation, I want to make it into exponential. I want to make the bases the same. So this is 3 to the x. This is 4 minus x equals 3x. Add x in both sides. That's 4x. X equals 1. So, I'm sorry. Okay, x equals 1. And that's it, right? That's how you do that. Next. So we can use the logarithm property, remember? Like from the first questions, we can move the -1 to the front, right? So we can say this is negative x ln of 6. And this is ln of 6 divided by ln of 6 in both sides. Negative x equals 1. X equals -1, right? Dividing by -1 both sides. Okay? That's the answer. So this is the graph, right? The thing that little takes time. Okay, here. Okay, so here, this is an exponential function. So you need to remember the exponential functions, they have horizontal asymptotes, right? And here the horizontal asymptote is this plus sign. So that's gonna be, in this case, y equals 8. So here I mean, this is kind of the best I can do. So that's y equals 8 here. And now you need to plug numbers. So the same thing I've been telling you forever, just plug easy numbers, right? Plug 0. Any number to the 0 is 1, times 5 is 5, plus 8 is 13. And you put 1, right? 1, it will be 23, right? Because that will be 3 to the first will be 3. 3 times 5 is 15. 15 times plus 8 is 23, right? And then you can put -1 just to, from the other side. So that's going to be 5, 3 to the -1 plus 8. This is equal to 8 plus 5, 1 over 3, right? Which is 5/3, right? So you can find common denominator here. That's going to be 29 over 3. That's going to be about, let's see, 9 2/3, which is 9.66, right? And then this is going to be 0, 13. So 0, 13 is somewhere around here. Let's put that in different color. 0, 13, let's assume that 0, 13 is about here. Let me erase this stuff. So 0, 13 is around there. And we have 123, sorry, 123, maybe about here. Okay, let's assume that it's about there, okay? 123, and then 81,9 point something, right? So 9 point about here somewhere, all right? And then you can trace it. Notice that they have a vertical stretch, right? It's a vertical stretch. This point doesn't go. It's a vertical stretch because you have these 5 multiplying that a term, right? Remember, this is CA to the x, right? This is the vertical compress. Why? Because this number is greater than 1, right? So that makes a vertical stretch, I'm sorry, not vertical compress, vertical stretch, okay? And this is just the asymptote. Okay, let's continue. So here, oh, I forgot the domain and range here. So the domain here will be all real numbers, right? From negative infinity to infinity. And the range will be from 8 to infinity, not including 8 because 8 is a horizontal asymptote, right? Just remember, if this is multiplying by 5, if this number is greater than 1, it's gonna be a vertical stretch, okay? If it's a fraction, it's gonna be a vertical compress. Okay, let's continue. Okay, so Here again is an exponential function, but there's no asymptote, right? You see there's no asymptote here. There's no plus or minus something, right? So there's no asymptote, so that assumes to be at 0, right? So you can just do your line right away, okay? Because this is a exponential equation, exponential function, you have a horizontal asymptote. So this is gonna be a y equals 0, right? And just plot numbers now, right? So plug easy numbers, 5, right? 5, that's going to be 0, that's going to be 1, right? If you put 5 here, 5 minus 5 is 0, then 2 to the 0 is 1, right? And what else? And then we can choose 6, that's going to be 2, right? What else we can use? But with this is enough. So 5, 1 is here, and then 6, 2 is here. So you can see the behavior. Maybe you can choose, I don't know, 3 maybe? I'm sorry. Maybe you can choose 3. So if you choose 3, it's going to be 2 to the 3 minus 5. So it's going to be 2 to the negative 2. It's going to be 1/4. 1/4 is 0.25, right? So 3, 0.25. You get the point. So you know how the graph look like anyways. Something like that. So this is what exponential growth, right? How do I know that? Because look, the a term is bigger than 1, right? If a is bigger than 1, that's exponential growth, right? What else I need to do? This is a translation 5 units to the right, right? That's what this thing is saying. Okay. That's it. That's it. Next. Oh, the domain and range. Domain is negative infinity, infinity. And the range is from 0 to infinity, not including 0, because that's the asymptote, right? Next. Here you have what? You have a logarithm function. So that means you have a vertical asymptote somewhere, right? And the vertical asymptote is basically 2 minus x equals 0. You can subtract negative 2 in both sides. It's up to you. Negative x equals negative 2, x equals 2, right? So the vertical asymptote is going to be at 2. Remember, when you're doing vertical asymptotes, you have to do the dot line. The reason I'm doing straight line is because I want to save time. Okay. Now I need to find points, right? So again, easy points. I'm going to put, let's see. I want to make this equal to 1, right? So maybe I can put, so if you don't see it, you can say, okay, I need 1 there, right? So you can say negative 2. So this is negative x equals negative 1, x equals 1. So x equals 1, right? That's going to be ln of 1. ln of 1 is 0. Minus 3 is minus 3, right? This is 0, by the way. Okay. And what else? Then we can use, we need to get e there, right? So 2 minus x equals to e. So negative 2 in both sides. Negative x equals e minus 2. But you have to divide by negative 1. So that's going to be 2 minus e. So 2 minus e, 2 minus 2.8 to round it, it's going to be negative 0.8. So negative 0.8 is this number. So negative, when x is negative 0.8, we get e. About that, right? Next is that we get e. We can put 2 minus e to make it simple. So when this is 2 minus e, then this is e, and ln e, by definition, is 1. So that means this is 1 minus 3, it's going to be negative 2, right? So this 2 minus e is approximately negative 0.8. So 1, 3, 1 negative 3 is about here. And negative 0.8 and negative 2 is about here. So you can see the behavior of this, right? Okay. Something like this. You get the idea. The domain, again. So in this case, this has to be greater than 0, right? The domain. So -2. So this is going to be -x less greater than -2, but you have to divide by -1. When you're dividing equality by -1, that flip, right? So that's going to be 2, right? So all numbers less than 2. So that's the domain. -infinity to 2, not include 2, and the range is all real numbers. Okay. More exercise. Okay. So here we have what? This thing. So here we can use because we have a positive, or we have a sum, we can write the logarithms because also they have the same base. This is the same, right? I can use the product rule, right? So this is going to be x minus 3, 2x plus 1. And this is going to be, I can move these to the top. So this is going to be ln x to the second power. So I have to do e. I'm going to write this as an exponential function. Remember, this is base e on the left side. So I'm going to write e to the ln x squared equals whatever is in the parentheses, right? This thing. Okay. Remember that a log a of x is just x. That's one of the properties of logarithms. And or if you have e to the ln, well, you know ln is base e anyway, right? That's going to be also x. So that's what I have here, right? So I'm going to use this property. So this is going to be just x squared. And this is going to be 2x squared. I'm doing FOIL now. This and this. 2x squared plus x. Now I'm doing this. -6x. And then this is going to be -3. So you continue. You subtract -x squared in both sides. So this is going to be 0 equals x squared minus 5x minus 3. Now you need to factor, but this is a prime trinomial, right? If you want to check, you can use a discriminant that we talk about in class. So at this point, I can only use the quadratic formula or completing the square, either one. I'm going to use completing the square just in case they might put that on the exam, right? So x squared minus 5x divided by 2. So b, I need to find this term, right? And this is going to be -3. So to find this term c, right? Let's call that c. C was b over 2 squared. So in this case, b is what? Well, remember, a is 1, b is -5, c is -3. So I need b. So b is -5 over 2 squared. So that's going to be 25 over 4, right? 25 over 4. And because I made this up, I need to subtract to keep equivalence. And this is equal to 0. Just keep that in mind. Okay. This is equal to 0. Okay. And now I need to continue. I need to, okay, so I know that this is going to be a perfect binomial. So remember the trick was I square this, I put x here. And you can think about, remember when we were finding this term right here, we used 5 over 2, right? Because that's what it was, right? -5 over 2 squared, right? So you can think about this number that is here, just put it back here again, right? So this is going to be 5/2 if you calculate it right. And then the sign in the middle is negative. So that's this perfect square trinomial. So now I need to combine, I need to find common denominator. So this is going to be 12 over 4 minus 25 over 4, and that's going to be 0. So x minus 5 over 2 squared. I'm going to combine these two, and I'm going to move it to the other side. So that this is going to be -37 over 4. If I move it to the other side, it's going to be 37 over 4. Now I need to take the square root in both sides, right? And every time I take the square root, I'm going to have two solutions, right? So this is going to be plus or minus square root 37 over 4. Or well, in this case, 2, right? Because we have perfect square of that, and add 5/2 in both sides. So if you do that, you get x equals 5/2 plus or minus root 37 over 2. Now you need to ask yourself this question, or you can write this as 5. You will have two solutions, right? 5 plus root 37 over 2, and this is x1, and x2 will be 5 minus root 37 over 2. Now you ask yourself this question, which one will cause an undefined situation, right? Now remember, you're not doing this with a calculator, so you have to think smart a little bit, okay? Think about this way. This is going to be positive, right? So let's work with the negative. Let's see what happens if I do that. So this is 5 minus, I don't have calculator, but you know that the square root of 36 is 6. So this is a little bit more than 6. Let's say 6.2. And you divide by 2. So this is going to be x2 equals 5 minus, well, 5 minus 6.2 is negative 1.2 over 2. That's going to be negative 0.6. About that, right? So if you plug that negative 0.6 here, you're gonna get a negative answer, right? And you're gonna have a logarithm or ln with a negative answer. So you know that that's not the answer right away. That's the extraneous solution. Okay. So this is the extraneous solution. So what's the answer then? Then the positive should be the answer. This guy, right? That's the answer. That's the answer. Okay. That's the answer. Okay. So let's continue. The next one, I'm gonna move this a little bit up because I have room right now. Do this. Okay. Should you practice this kind of stuff? Okay, next we have this thing, ln. So the first thing I'm gonna do is I'm gonna add this in both sides. Okay, so this cancels. You have 5 ln x minus 3 plus ln x minus 3. So you can think about this is like saying x plus x. So that's gonna be 2x. So this is gonna be 2 ln x minus 3 equals to 5. Right, divide by 5. You get 5/2. Now you write this as an exponential function, right? Like this exponential equation, I'm sorry. So this is going to be e. Remember, when you have log a b of c, you write this as a c equals b. That's what I'm doing right now. So e, because remember, ln has base e. E to the 5/2 equals x minus 3. So now I need to add 3 in both sides and I'm done. Right? X equals e to the 5/2 plus 3. That's the answer. Okay. Next. Here. Remember, this is base e. So I'm going to write as an exponential equation, right? So e to the 0 equals log x. So e to the 0 or any number to the 0 is always 1. Log x. Now I can write this as what? As a exponential equation one more time. Remember, this is base 10. If there's no number, it's assumed to be base 10. Okay? So I can say 10 to the 1 is x. So x is 10. That's it. Next. They're asking you here, the second hand of a clock on a clock is 6 inches long. So just draw a picture, right? So you have two clock hands, right? So one is the shorter one, which is for the hours, right? And then you have a longer one that is for the minutes, right? For the seconds, I'm sorry. Let's assume that this one is the one for the seconds. Okay, this one right here. Now they're saying the second hand. Let's assume that the pink one is the second hand is 6 inches. So that's your radius, right? Okay. So how far does the tip of the second hand move in 15 seconds? So you have to recall that one revolution, right, is 2 pi radians. And in this clock, right, in this clock, one revolution is 60 seconds. So they're asking you about 15 seconds, right? So if you can think about like, okay, so if I get on this side 15 seconds, then I can see what's the how far did it went in radians, right? So if you divide this by 4, you get 15 seconds, right? And this will be pi over 2 radians. So that means in 50 seconds, how far did it went? It went pi over 2 radians, right? And they're telling you to use this formula right here. This is the arc length, right? S is the arc length. R is the radius. And theta is just the angle in radians, right? In this case, it will be pi over 2, right? After you figure it out what it is. Okay. So here, they're asking you, a merry-go-round makes 8 revolutions per minute, right? What is the angular speed of the merry-go-round in radians per minute? Okay. So first of all, they're asking me for omega, right? So in this case, I have 8 revolutions per minute. You have to remember this. One revolution is 2 pi radians, right? And since they're asking me just for radians per minute, the only thing I need to do, this is like kind of like you have to cancel units, right? So here you can cancel the revolution, and this is going to be 16 pi radians per minute, right? So that's it. That's what they're asking you. What is the angular speed, right? The angular speed is this formula that they use here, omega, okay? That's it. Okay, and then the next question is asking, they're asking you how fast is a horse 12 feet from the center traveling using this formula, right? So this is the linear velocity, and this is the radius, and this is the angular velocity. So this is the linear velocity. This is the radius, and this is omega, which is the angular velocity, okay? So how fast is a horse 12 feet from the center traveling? So you draw a picture again. What happened? Yeah, you draw a picture from the center. The horse, let's assume that that is here somewhere. And you know that it's 12 feet from the center, they say, right? Let's assume that this is the center, okay? It's 12 feet from the center. So use the formula, right? So you know what's the revolution. So you just need to, the radius is 12. So you just need to find the speed, right? So this is going to be 12 feet per radian times omega that you find from the other part. So this is going to be 16 pi radians per minute, right? So this cancels out. You get, remember you don't have a calculator this time, so you can just do 12 times 16 pi, right? Feet per minute. So I'm gonna do the multiplication. This is gonna be 10 plus 2 times 16. It's gonna be 160 plus 32. That's gonna be 192. 192 pi feet per minute. So that's the velocity, right? How fast, right? How fast means velocity, right? How fast it's going, right? That's it. That's it. That's all you have to do. And the last one, they say if it is known that log 3 log 4y equals to 0, what is the value of y? So you do the exponential equation again, right? So this is 3 to the 0 equals log base 4 of y. That's 1 log base 4 of y. So you can say 4 to the 1 equals y. So 4 equals y. That's it. You're done. And that's the entire exam. There's nothing more. This is I just need for graphing. That's it. Okay. I hope this helped you. I'm gonna record maybe later on. I'm gonna record the homework. Okay, the assignment that I give you, the 50 something problems, and I'm gonna try to finish the other lectures from 4.2, 4.3, 4.4. If I don't have time, I will just put the examples or practice questions similar to that chapter. Okay. Thank you and have a nice day.